This recent paper in Science Advances is really a piece of innovative work that combines two unique technologies. One is the quantum confined nanocrystals that came from our group, with the CMOS vertically stacked optical imagers that came from Professor Gruev's group. I think it's going to open really great opportunities in cancer imaging, image-guided surgery, and in cancer diagnostics.
This idea really goes back probably about 5-6 years ago. We just had a coffee with Professor Shuming Nie, and he was telling me about his work on perovskite nanocrystals. They have this very interesting optical phenomena, optical properties. They can absorb lower wavelengths, such as ultraviolet light, all the way to X-rays, and then they fluoresce in the visible spectrum. We're using the autofluorescence from ultraviolet light to be able to discriminate cancerous cells from healthy cells. It started more as a basic science sort of project. How do we make these crystals? How do we integrate them with camera technology? And then once our graduate student Cheng, when he was making progress with this camera, it became more and more obvious that we can use this type of sensors for many biomedical applications.
So what we do is to deposit the nanocrystals onto the image sensor, and we fabricated a nanocrystal coating on the sensor. In this way, the sensor will gain the ability to see the colors in UV, which means it can discriminate the UV wavelengths. And an interesting fact is the tumor cells and healthy cells will exhibit different colors in the UV. So we can use it to discriminate tumor from healthy cells based on their colors.
One of the tasks during surgery in particular is to be able to identify cancerous lesions and make sure you or the surgeons removes everything. So what this technology is enabling us is to identify where some cancerous tissue is left. We are really using some of the intrinsic signals that are generated by the tumor tissue. So that makes it very easy to translate it into the surgical suite.